All right, hey 6A. So now we're going to be on pages 207 and 208 of our packet, and we're going to take a look at solving one-step equations with multiplication and division. So I'm going to make myself a little bit smaller here. Okay, so now we are multiplying and dividing in our one-step equations. So some key vocabulary. We're going to have a lot of that same vocabulary that we used with addition and subtraction is going to apply to really all equations, okay, including multiplication and division. So take a look at my last video of addition and subtraction one-step equations to get some of that vocabulary if you're stuck with that. Other vocabulary we're going to keep in mind, we're still going to be really focusing on that word balanced, right? Each side of my equation having the same value. And we also are going to be taking a look at a tape diagram, or in this packet, they are also calling them a bar model, okay? So a tape diagram and a bar model are the same thing, okay? And we're gonna use that to model what's happening with our addition and our multiplication and division one-step equations. So follow along on page 207 and 208. I'm gonna be taking a look first at the example that's on page 207. You can read what's at the top there, okay? I'm not gonna read that right now, but hopefully you've taken a second to already read that to yourself. If you haven't, I want you to pause the video here and read that. Okay, but if you've already paused, hopefully you've read that, and now we're gonna keep going. So it says, really the equation that's modeled in the balance of the picture that's drawn there is 3x equals 9. So you can see that I've written that on the left side of my page here. We have 3x is equal to 9. Now, something to keep in mind, and that I'm going to notice as I look at this equation, is the 3 and the x are right next to each other. That 3, the number in front of my variable, is called a coefficient. But we know that when I have a coefficient and a variable right next to each other, that means that we are multiplying. Okay, we talked a lot about that in class. So we've got multiplication. So the first thing that I ask myself, same questions as my addition and subtraction equations. First question is, what operation do I see happening here? Okay, when I look at my equation, I see that we are multiplying like we just talked about. So I have 3 times x. The second question I always ask myself, what is the inverse of multiplication? What is that inverse operation? The inverse operation for multiplication is division. So I'm going to write division as a fraction. Okay, you're going to see that a lot more as we are going further along in our math journey. So I need to divide by 3. So I'm going to divide both sides of my equation by 3, right? In order to keep them balanced, if I divide one side by 3, I need to divide the other side by 3 also. So I know that 3 divided by 3 is 1, right? So this is really 1x is equal to 9 divided by 3, we know is 3. Okay, but I don't necessarily have to write 1x, right? I know that 1x can be written as just x is equal to 3. So my solution is x equals 3. When I'm multiplying and dividing, I really want to make a 1 in this case instead of a 0 like we did for addition and subtraction, because I want to know what just 1x is equal to, right? 1 copy of x, not 3. If I were to draw a bar model, or as we've used in class, a tape diagram for this, I could show that I have 3 copies of x, right? This is the same as 3 copies of x, right? 3 copies of x is going to be equal to, I know that this whole thing is equal to 9. So something we've done in class is, if I know that 3 copies equals 9, if I want to know what just 1 copy is equal to, right, then I know that I need to divide both sides by 3 in order to figure out what just the 1 copy is, right? Divide that 9 into the 3 boxes, and I will see that each one box, each copy of x is going to be worth 3. So we're going to get the same answer either way, okay? This top part we solved using algebra, okay? So if they ask you to solve using algebra, that would be that top section. If they ask you to draw a bar model or a picture, right? That would be, or a tape diagram. Okay, there are lots of ways that you could be asked to do that. That would be that bottom section. You can do either one, whichever one you're most comfortable with. So I want you right now to pause your video right here, and I want you to do those 2 examples on the right on your own, example 1 and example 2. So go ahead and pause. And hopefully you're finished. I know hopefully you've unpaused that video and you've already done that on your own, and you didn't just wait for me to go over the answers with you. I know you did. We're going to use integrity, and I'm going to trust you. Okay, so let's take a look at number 1. First question, what's the operation? 5 and x right next to each other, I know is multiplication. Second question, what is the inverse operation? Well, I know the inverse operation is division, so I'm going to divide by 5. In order to keep them balanced and to isolate the variable, I need to divide both sides by 5. 5 divided by 5, that makes a 1, right? So this is 1x, or just x. Then on the other side, 20 divided by 5 is 4. So my solution is x equals 4. Number 2 is a little bit trickier. Same thought process. First question, what is the operation that I see? I see division. Second question, what's the inverse operation for division? And that is multiplication. So I'm going to multiply both sides by 2. Okay, same as before. 2 divided by 2 on this side makes a 1. I kind of have to draw it at a little bit of an angle there, okay? But so I have my 1x, and then 10 times 2 on the other side is 20. So my solution is x equals 20. As always, if you have questions, put them in the comments below, or you feel free to text me or reach out to me on Dojo.